I could do some whining, but
Whining always makes us feel better.
well, my car wouldn't start today, so I'm at home, so I can join the meeting.
Brr.
So I'm not going to lunch today at work.
And in Pittsburgh, I think it's 40 degrees going to 17. What's it in Minneapolis?
Well, it's my car said it was -7, which shouldn't have been cold enough for it to not start, but it wouldn't. So I don't know what the problem is. I put some heat in the gas tank, and the last time around, I decided that when it gets cold and everything gets stiff, it could be the injector. You pulse it, it just doesn't open because it just acts like it's not getting gas. So I'll let it warm up again and move on, I guess.
Heat as in a thermal device in your
No,
gas tank, or heat as in a product?
heat as in a product. It's what is it? It's not isopropyl. It's methanol. It's just a bottle
Additive.
of methanol you pour in, and that's supposed to absorb the water that's in your
Right.
gas. So if that was the problem, that should help.
Anyway, I digress, being curious about the frigid temperatures of Minneapolis. So, Matt, do you want to just, because I think this is a healthy conversation personally for everybody. Do you want to recap for Jeff and Sohin your debugging process?
On the lawn tractor, I started noticing my sensor values would get spikes, and I have not figured out what system is causing those spikes yet.
And so you, on your desk check, did you have all the same sensors connected, or was it a duplicate set of sensors?
It wasn't a complete duplicate. I have the same steer encoder, the same steer potentiometer that I was testing with. And
then when
I'm not driving the same motor.
And when you moved to the lawn tractor without the engine running, did you get the spikes?
Yep.
With a different 12-volt supply, did you happen to try a different 12-volt supply?
I'm using a battery. I haven't separated out the another battery.
Not that I thought that would be it. I was just curious. So even with the engine off, so it's not engine noise.
Yeah, and right now I even turned off. Right now, the only sensors I have plugged in and the only system I have up is the Citron motor controller for the electric power steering, and then the potentiometer for the steer angle sensor.
Can you sort of recap the differences between the desk environment and the actual lawn tractor environment? Because seriously, if nothing's running, if the motor's not running, that's a huge, wow, we should be able to figure this out. What's different between the desk check and the lawn tractor?
Well, one difference, I used a wall 12-volt supply.
Is your RC servo hooked up at this point?
RC servo right now is disconnected. Power is disconnected. I do have an USB cable from my laptop going into the Pro Mini, and I'm measuring the PWM signal from the Teensy that's going to the servo motor.
So my thought is it's your steering motor. Anytime you pulse that, that's going to cause noise on your electrical system. And even if you're not telling the steering motor to control, it's got a feedback loop, and it's just going to randomly be putting out little PWM pulses one way or the other to keep it happy. So to find out if it is that motor that's generating the noise, just go into your code and say, don't output the PWM values to your motor controller. That way everything can still be wired up the same, but just go in the code and say, don't actually put out any pulses to that motor control board. and see if that isolates it. Because I'm guessing you've got that big motor on there, and anytime you switch that motor, it's going to put noise into your system. So that's something you can check.
In your desk check, did you have a motor and the motor controller operational?
At the motor controller, but not the big electric power steering motor.
Was there ever any load on the motor controller in your desk check? I mean, were you sending it signals?
Yes, but no load. Kind of what I'm doing now is I have everything disconnected pretty much. There are a few, I'm still measuring the reverse sensor on the lawn tractor, and I'm still plugged in to the harness, the OEM harness. But the main things that are connected are the steering motor controller and then the potentiometer. And then I send in a steer command to move the steering wheels halfway, and then I move it back. And then when I move it back, it will like start to hunt. As the steer sensor is sending back, instead of let's say it's 500, it would be center line or center steering, and then it'll do like 500, 520, 480, and so then the steer motor is trying to control to noisy signal. And I also see those spikes when I'm measuring the PWM that's being sent to the servo motor.
Yeah, I mean, if you don't, even if you had a small DC motor, I mean, it wouldn't be the same, full test, but on your desk check, if you could even connect a small DC motor, again, you're minimizing the differences to see if that motor controller under stress is doing something wacky.
Yep.
So I had exactly the same problems that you're seeing, and I was running that linear actuator on a Cytron motor controller, and there's a potentiometer built into the actuator. And when I would get signals back to the analog input, they were extremely noisy just because the PWM on the motor is generating all kinds of crap on the power supply. So the first thing I did, I put an RC filter right at the input of your analog input. So right on your board, I think I used a 100K resistor and a 0.1 microfarad capacitor. And if you go look that up online, I think it's something like a 16 hertz low pass filter. And that gets rid of most of the crap coming in right there. And it still was randomly giving me noise. So it would cause my steering motor I could hear it thump every once in a while because it was picking up noise from somewhere. So then I went into the analog input and did an averaging. So you read it, have it running at a fairly fast rate and just keep a running average of the values coming in. I finally got it calmed down to the point where it seemed to work okay then. And then as far as your other one where you're trying to read your PWM, let's see, that was on that was inside of the servo. You were trying to read the PWM and it was giving you stupid values there. You see noise pulses there or something?
Yeah, when the steering wigs out, when the steering starts buzzing around, then I can also detect it on the PWM to the servo. And sometimes it will wig out enough that the servo will start to move, like it affects the actual servo.
Yeah. So again, you can do the same thing on that. Even though it's a digital signal, you can still put a low pass filter on there. So it's filtering off any extra noise spikes that would be on the data coming in, because that's a digital signal coming in, right? You're generating a PWM on your TNC and you send that to the little Arduino board on your servo. So that's digital all the way through there, I believe. But you can put a low pass filter in series with that line and get rid of a lot of stuff that's on there.
So you're using a 0.1 microfarad and then a 100K resistor?
That's what I'm using on my analog input, yes. So I've got a potentiometer. I think I had it's got a 10K potentiometer. So I tried to keep the resistor of my low pass filter 10 times that size. So do you recall what your potentiometer is you're using on your steering? What value it is?
I think it's a 10K.
Okay, so that would be basically the same thing I'm doing then. And just some rules in electronics. I think your filter, you want it to keep it like 10 times greater, the impedance 10 times greater than the thing you're trying to measure. So that's why I went with a 100K resistor and a zero point 0.1 microfarad capacitor. And I say it gives me like a 16 hertz low pass filter. And it turns out on your steering, you're close to DC anyway, so you could put, whatever capacitors you have around, try putting on there, and you can just play with it. But you could get pretty extreme on the filtering because coming off the potentiometer, it's not going to matter that much. Now, in the case of if on the digital side, if you're going the signal to your servo, you can't filter that too hard because then it starts rounding off the edges of your square wave, and it's going to affect the way it works. But you should be able to calculate something that would that should work well enough to get rid of the spikes that are being generated on there.
So I like the filtering, but it always kind of bothers me not having a clean signal from the sensor.
I would agree on that, but you're going to try to track down all these things that are causing the noise, and if you can't quench it completely, that's the next step. You have to say, okay, well, that's just the world. We're going to have to figure out how to filter the stuff out and get rid of it.
But Matt, walk me through. I mean, you were able to drive the lawn tractor, I'll call it manually. Why didn't you see erratic behavior when you're trying to drive it manually?
Yeah, that's a really good question. That's one of the things Brett, I used to work with a guy, Brett, and I used to break the robot all the time. And Brett would say, what was the last thing you changed after I went round and round and round trying to figure out what was going on? Because generally, exactly, like if I was on the joystick and I moved it to a position, then the wheel would move. If I let go of the joystick, the wheels automatically come back to center. And I didn't see the erratic behavior. I did tighten the range, so I don't know what you want to call it, the control range. There's like a dead band.
Right.
So let's say that 500, number 500 is when the wheels are in the center. And I called it, the dead band was like from 490 to 510. So as long as the sensor was reading in that position, then I would say, okay, you're at center. I did recently tighten that up to try to get tighter control as you're moving and you want to do path control and you want to stay on the line. I didn't want to have that much play in the steering system. But that's one change I made. And then another change I made is I put the second pickup sensor on the vehicle so I could have odometry. So I would know the difference of wheel speeds from left to right. I have since, well, I haven't opened up the dead band, but I've removed the pickup sensors. I've unplugged them.
Have you tried, just out of curiosity, have you tried to steer it programmatically? And by that I mean, say, like a simple Python script without any ROS modules running?
No, that is a good test. There is a teensy script in there for the servo sweep that just reads in the potentiometer and then controls the motor, So something like that. Remove all the raw stuff and then start with a clean code base on the teensy. Is that what you're
just, I mean, again, because you could steer it manually, I would have thought, if you think through it, using your old steering control system under manual control, you're saying unless the potentiometer gave you some reading when you're going straight outside of that band, let's say 490 to 510, you would expect it to keep going straight, right?
Yeah, for the motor not to be active. Yep.
And so I'm assuming the spikes you're seeing would be outside of that range, right?
Yes, they are. They're like
let's
say 530 to maybe 480, 470. kind of in that range. 20.
So, I mean, from a debugging thing, I'm like, why is it driving straight under manual control? And evidently, I don't know, what do you turn on when it, help me understand what's the difference between the manual control and when you're seeing these erratic spikes? Are you
Nothing.
firing up raw, or what are you firing up?
No, it's all runs that the base, the teensy controller, the microcontroller is listening for a command velocity message. And so whether I'm on my laptop, right now what I do on my laptop is I just do ROS topic pub twist message and then set the wheel angle that I want. But that's exactly what the joystick does. So from the robot side, it doesn't know that the joystick is sending the command velocity message or the computer is sending the command velocity message. It's just listening to that.
So where's your wiring from your potentiometer? How do you have that routed on the vehicle? Is it anywhere close to any of the other power wires? You're going to have 3 wires going out to your potentiometer. Where are those running on the vehicle?
So those, the steer sensor is down low on the base. And so it comes out like you said, 3 wires. I have plus or minus 5 volts, and then I have the signal wire coming back. And so those 3 wires come out of the box and down along the base, and then right in front. It's not even tied on the same loom as the power for the motor controller, because the motor controller is up high in the little box and the steer sensor is down low where the gear is. I may switch over. I may rewire that sensor or I have an extra potentiometer, so I'm going to try switching that out and then seeing if I'm getting the feedback. It's coming from somewhere. It's bananas.
Right. Yeah, I'm just back to, is it a hardware issue or a software issue? Right now, when you reduced your acceptable band, will it drive straight under manual control if you just leave the joystick unmoved?
Yeah, but you every once in a while you get bad sensor data from the potentiometer, and then the wheels jitter, and that needs to be solid. The filter is a good idea to chop those out. It's a RC it's a hardware filter. I did start to do a software filter, like averaging. You do an exponential average, but I guess I don't like the noise. One of my professors in college, I did research. He said that your analysis is only as good as your sensor readings. Your data. If your data is off, all of your analysis will be wrong. So always remember that and try to calibrate and make sure that the sensors are accurate. I spent a lot of time calibrating sensors.
And so, Jeff, this 16 hertz low pass filter that you mentioned earlier, where physically do you put that in the path?
I would put it on my.
Okay.
Yeah,
Matt,
I like it.
And as far as deciding what's creating the noise, anytime you have these big motors and you're driving them from a PWM, they are going to generate noise. Now the question is, what can you do to get rid of that? So it's possible you could put some kind of a filter right at the input of your Cytron motor controller. So you've got wires coming from the battery, it would come to this thing, and then right at the input where you're putting the power into that thing, you could put some kind of filtering there to keep the noise there from getting back onto the battery bus.
I put a 0.1 microfarad cap on the leads going to the motor.
You might want to put something big on there, put 100 microfarad or something like that right across that at that point, and see if that, again, see if that helps. Do you have any fuses between, do you have any fuses from the battery going to anything, or is it, I think the Citron might have a fuse right on the board. So I just
Yes,
wondered, do you have any extra inline fuses anywhere?
I do. I have three separate fuses. I have one fuse that goes to um, the steering motor, one fuse going to the servo, and one fuse going to the electronics power.
Because what I found out the hard way was fuses are surprisingly have a lot of resistance. And I found that out because when I turn on a motor controller, which had, I think I had like 2,000 microfarads of capacitor on the board, and when I'd turn the power on, it would drag the battery voltage or drag my bus down to like 2 volts or something. So if you'd watch it on a scope, as soon as I flipped the switch on, it would go from 24 volts down to 2 volts and then rise back up with an RC time constant. And it turned out to be, because I kept thinking it can't do that because a lead acid battery is very stiff. It's got a very low internal resistance, which means it cannot do that. So I started probing around with my scope, and it turns out the fuse was acting as a resistor. So I had this big capacitor out here, and when I switched that on, the resistance of the fuse drug it allowed it to pull that line down to about 2 volts or so. So what that means is if you got those fuses in there, you could put say a big capacitor on the other side of the fuse. Number one, you might want to put a capacitor right across the battery lead. But as they say, a lead acid battery should be stiff enough that it's not going to care about that. But on the other side of every fuse, put a capacitor to ground there. So you might want to do this all by the battery if that's where your fuses are. Oh, you've got that fuse block, right? That little plastic.
I pulled the fuse block out, and now I'm running it back to where the power is from off of the battery. So it goes through a relay. So I have an automotive relay, and then the electronics gets power through a switch, a physical on-off switch, and then the motor power comes from this automotive relay. And when the electronics get booted up, everything is okay. Then I have a ROS service that turns on this relay. And when this relay kicks, it sends power to the servo, and then it sends power to the automotive steering thing, the electric power steering. And and you do see a lot of noise when that relay kicks. The steering starts to jitter, and the steer sensor is going bananas.
Okay, so what I would do is on the output of that relay, well, on the other side of the fuses, I think is where you want to put a capacitor. So if is all that close to the battery, or is it where is this stuff physically located?
It is close to the battery, but it's mounted down by where the starter is in the back. So the battery sits here, and then there's a starter down here, and then automotive relay is here.
Okay, so I would say, right on the other side of those fuses, since those fuses are acting as resistors, put a capacitor from there to your ground bus that goes back to the battery. And you could do this one at a time and see if that improves the problem or not when you do this.
Pretty good size, a pretty hefty size, 500. What size
capacitor?
Yeah, what size of capacitor?
500,000 microfarad, something, like a big electrolytic capacitor. It just makes you get the voltage, pick like a 50 volt capacitor or something, so you don't have to worry about exceeding the voltage rating on that.
Okay.
But I think you want to go through each motor at a time and figure out, how to quench any noise that is generating. The other thing is there may be some way to go between the motor controller and the motor itself, do some kind of a network there that would get rid of noise that's being generated by the motor. So it could be, over on that side, you need to do something to get rid of these noise spikes at that point. But then definitely going back to your main power, the more you can isolate that down and keep it from spreading throughout the system, the better off you're going to be. And I haven't played with mine hard enough to figure out what to do on that. But as I say, it came back to that thing, the realization that fuses act like resistors. that really surprised me when I found that out.
I didn't
And
think
that
about
could
that.
add to the problem there. So basically, if you had it tied directly to the battery with no fuses in there, then the battery's not going to let those big spikes come through, because lead acid battery wants to hold it right at whatever voltage it is, and it's not going to let the spikes go up and down. And then once you put the fuse in, now you've isolated it, so over at the motor controller, it's free to swing up and down because you've got a resistor in between that and the battery. So it's just, little things like that to try to figure out.
So just
That's
for
a good
testing, and it
suggestion.
would be completely unsafe for production, but do you want to jump the fuse?
Or
You
or
could
you
do
could
that.
put the capacitor on there, and then if that takes it, then you know that that's the draw. There is a draw. I didn't even think about there's a drawdown on that line. But that would explain why when that automotive relay kicks, the sensors start to go bananas for a little bit of time, and then it recovers.
And even on that relay, you might want to put a diode across the coil, because, again, being an inductive part, you're switching on and off, that will generate a big noise pulse back into your system. So if you put a diode across there, reverse bias, so you're not shorting your power supply out. Just look up relays and diodes, and it'll explain all that. So that's another source. As you're switching that on and off, you get a big noise pulse that's going to go somewhere.
On the big servo, the super servo, I did put 3 capacitors. I put a 0.1 microfarad across the input leads and then grounded out the either sides, and that did seem to clean up or lessen the spikes on that on on that side.
And it could even be that you have to get fancy and put, say, an inductor in series with it. Look up. You might want to look up motor filtering or motor noise problems, and they might have, so close to the motor controller, say, and also close to your servo, which has a built-in motor controller. You might have to put an inductor in series at that point, and then put some capacitors somewhere around that so the inductor keeps the pulses from going back on the power supply line, and then the capacitors would then short it between the supply and ground at the device to cut those off and get rid of them. So there may be various things you could do here to fix that.
Okay, thanks. That's good. It's always helpful to talk these out and have different opinions and experiences. I didn't think about the fuse being a resistor.
Sometimes just talking it out, then since you're the closest to it, you think about other options as well. So hopefully it's been helpful. On my end, just a quick update. Find sharing again, Zoom.
Oh, one more comment on that. I was saying it could be that's between your motor controller and your big motor. There might be something you could do. Take some of those ferrites you got and put onto those leads there by the motor. So between the motor controller and your big motor, try putting those ferrites on those leads, maybe close to the motor, and see if that helps also.
On my end, made a little progress on getting a motor mount constructed, so I think I'm ready to actually apply some power to this. In order to do that, I need to looking for sharing again. New share. This is my motor, and I know that from this edge to where's the annotate? So from this edge to this edge, I know is 100 millimeters. So I've got to whack my shaft basically at a point to make sure that that's 100 millimeters plus or minus a couple of millimeters. So that's my next step. So I was going to whack that and then use JB was it JB Weld? I forget that
You're going to
stuff.
drill it and put a roll pin?
I don't know. This looks like hardened steel. That I mean, I think that's hardened steel. I don't think I'm gonna drill that. So I was going to try the either weld it properly or just for testing use what's that stuff that you found that supposedly is strong as aluminum?
JB Weld, but I have. There's not a lot of. If you have two smooth surfaces, I wouldn't know how well you're gonna put JB Weld. The inside of your U joint shaft is smooth, and then your rod is smooth.
So you don't hold much hope for that?
Well, I mean, like you said, for testing, if you want to test it, if you know, I just don't know how much force, and I wouldn't know how long it would last.
Yeah, I mean, I can put the rod in there and give it a go drilling through that. We'll see if I mean, my drill press is a proper drill press, right? So I can give it a go, even with the small diameter bit.
Yeah, just as a quick test, try to drill it just to see what it does. You know, even just take a hand drill and any bit you've got just to see if it's going to be act like it wants to drill or if it is hardened. That'll tell you real quick.
Yeah. So that's my next step.
One thing that on that U joint, you see where those set screws are. That goes around that little horseshoe dip on the output of your motor.
Hold on a second. I'm trying to get this annotate off so I can.
So is it 100 millimeters if your U joint is put on your motor?
Is it 100 millimeters if my U joint is? It is 100 millimeters from this bolt.
Yep.
To the top of the gear.
That's
and
how
I know
much
that
space you have.
right. That's how much space I have.
Okay.
And I know that because I have basically 100 millimeter bushing holding the motor up while I was fabricating the motor holder. So now I've got to go back and now I know that's the constraint, and I've got to make use of live within that constraint.
Okay, and so then I was curious about the distance between the bottom of that nut to the bottom of your U joint when your U joint is mounted.
Bottom of the nut. Oh, I don't know. I can measure that certainly. But I was. How do I clear the annotation? Clear. Now I've got annotation back on.
I guess the long and the short of it is I cut my steering shaft too short. So like let's say I only left a half of an inch, and that half an inch would go into the bottom of your U joint. And then what happened with mine is that U joint now is almost resting on top of the pinion gear at the bottom of your steer shaft. And where you run into an issue is when you mount the other pinion gear with the steering coder. Mine was up about like a millimeter, and there wasn't room for it. So Jeff mentioned you can leave a little bit of room. Like if you left a half of an inch, let's just say half an inch between the pinion gear and the bottom of your U joint, then when you mount your steer angle pinion gear, you'll have a little bit of flexibility if you're going to mount it down at that level.
And one more time, the half a joint that you're talking about is where?
The half of an inch is between the top of the pinion gear on your steer shaft.
Here's the pinion gear, yeah.
Yeah, and the bottom of your U joint.
Yeah, I'm assuming that's going to be about Yeah, I think I'll have that.
Okay. Just lessons learned.
Yeah, because well, I'm just trying to. Oh, I should have that. I forget how deep that is. There won't be a ton of space down there, but there will be. I think there'll be that. Yeah, so I'm just going slow on this cut because just like you, that's for me. It needs to be very precise, and I don't have a lot of wiggle room.
That's why I was curious of the distance between your nut there and the bottom there when this is mounted, because though this point gets mounted here, so the
Right.
distance from this point to this point, I'm curious, and then you'll want to leave about a half of an inch here,
Yep.
and then if this is a half of an inch from here, then your cut point is a half an inch above that.
Exactly.
But, yep.
Okay, so that old saying about cut or measure twice and cut once. I'll be measuring 50 times and cutting once. And I'll probably still screw it up, but we'll see. This is
What you might want to do, get a wood dowel that's the same diameter as your piece of metal there, and use that and put that in and cut it to the length you should think it should be, and see if it all fits. And if it does, then you can go cut your metal shaft.
Yeah, that's a good idea.
Yeah.
So this is the mechanical side of robotics, right? Jeff, anything on your list you wanted to share today?
I can't think of anything right offhand. I did get my super servo in the mail, so I've got that, but I haven't done anything with it yet. So it's just kind of laying around. Other than that, I haven't gotten anything done. So
I have been in some of the downtime trying to 3D print a bracket for that super servo. So anyway, I don't know if you mounted that, Matt. In your pictures, it should show just a small amount of clearance between the fan on the transmission and the super servo. How much clearance would you say there is between the fan and the super servo?
I could measure it, but maybe like a half of an inch.
That
maybe
much?
A little bit more.
And then you mount the mounting bolts that you used. Are they going against that back plate?
Exactly.
Yeah.
Yep.
And you just drill those out.
Yep. I went to Home Depot and bought a hinge, like it's an eighth of an inch hinge, and then cut it in half and put half of it on top, half on the bottom. I used a thinner metal originally, but that servo has so much torque that it was kind of bending the mounting bracket. So I went to a thicker one.
You say you used a hinge.
It's just like an angle bracket. It was like $1.50, eighth inch angle, and then just cut it in half, and then mounted one on top and the one on bottom. So it's pretty big, maybe inch and a half.
But it was an angle bracket as opposed to literally something with a hinge. It didn't have
Not
movement.
a hinge.
Yeah, okay. Sohin, anything on your list? How are you doing?
No, I'm just working on stuff at work, so nothing really on my end. I do feel the need to get back to my TX1 because since I can't just see it, sitting there. So, but yeah, nothing in particular. I don't have any of the cool stuff like you guys do, like any of the hardware except for a computer. So probably do something simulation related rather than spending money on hardware at this
We
point.
could probably fix that if you had space to have some hardware.
Yeah, no, that's the thing. I don't have space for hardware. That's why I don't have any hardware. But Yeah, I'll do something with simulations first and see where it goes. There's a lot to be learned on the simulation side as well. So
You're absolutely right. And the
playing around.
microphone that you're using today, you're coming in clear. Are you using the microphone in your headphones, or do you have a separate microphone?
I have no idea.
Um,
Yeah, I'm using the microphone in my headphones. So yeah, I
oh,
got the new ones
blows
finally.
me away how they figured out directional microphones in headphones.
Yeah, it's nice. So
And Colin, anything you want to report on?
Nothing in particular. I'm going through a particular book which I'm using. It takes you from, well, it's heading, it's learning robotics using Python, design, simulate, program. So it starts with, there's two ways of looking at a robot, whether you are going to design your own robot or you are going to use a robot that you have acquired from somewhere. So we go through basics really, how to calculate the size of the motor given the weight and all the things that you guys already know. But I think it's very good for me because I tend to look at the design. What do they consider when designing a robot? Even though I'm not going to design one, I already have my lawnmower that I'm going to be using. But it is helping me to understand the size of the wheels, the diameters, what it all means. And the things that you talk about here on this meeting is beginning to make a lot of sense as I go through the book. It has got some questions and some solutions, the things you need to worry about. At the end of the day, when I finish the book, they say we are going to have done worked on a robot with the two wheels and two balancing pseudo wheels. It's a robot that serves meals in a hotel. They've got all the things that you need to know about controlling that robot, avoiding obstacles and stuff like that. So I'm thinking that, and also the other aspect is that the equations that you go to formulate to arrive at how you are controlling things. I'm finding that more useful that if you have to control something and you go to formulate an equation for it and so on, though it's not easy, but at least I'm getting some guidance as to how to do that. By the way, this is not the only thing I've had to look at. I've looked at some things which I realized later after spending 2 weeks that it's not going to make me, it's more of a research professor's type of stuff rather than the one that makes me to go to my lawnmower. What I want is to rip off the lawnmower and begin to do things that you guys are doing. But confident building is what I've been working on. And I think I'm on the right track. But I haven't reached a stage where I share anything with you yet.
That's a good update. It's certainly for me, I can say that it's been a long road and it's a little bit of learning, and you learn a little bit and then you try to apply it, and then something you tried to learn a while ago then becomes clear. So that's I think you're on the right road. One other thing that I'll share while I've got you, it's sort of related. Here at I work for a natural gas company that finds and delivers natural gas, and we had what we refer to in the business as a well control event last week, which effectively means pressure on a well that was, I don't know, 13,000 feet deep. There was an anomaly in the well, and when that happens, you don't know what's going on, so you could have the loss of containment and we happened to be in the Appalachian Mountains, and so we were struggling not communicating, and we're now looking at. We ultimately used 800 megahertz radios, which are some of the same radios that are used by first responders, and we're looking at other ways to communicate in a hilly terrain effectively, and we came across these guys. Am I sharing my screen? Seeing my screen, Matt?
Yep.
These guys called tactical helicite hotspots. Effectively, what they do is they have engineered a balloon, and it can carry a small payload. And based on, you can put something in that payload that helps your communication. One of the things that they advertise that people put in their payload is effectively either some sort of radio or a MiFi, or if you haven't heard of these things, the Go antenna effectively creates like a mesh network. So these things are survivable up to, they have different ratings about how fast or how much wind they will take and what their payloads are, but imagine about 1,000 feet off the ground, and it can survive 40-mile-an-hour winds and carry basically a pound. So it's Matt, when you have to have communication coverage in a hilly area for all your robots, this is something you can put on your maybe list.
It's awesome. That helps. Getting up tall helps.
So it's been interesting to try to figure out what to do because a cell tower on wheels is $100,000. Well, can be $100,000 item depending on how high you want to get, and you're only going to get about 100 feet up if you spend a bunch of money. This is getting way up there, but then comes with every few days you got to fill it back up with helium. So it's been interesting.
Are you gonna be trying these units?
I think we're going to spend money on one of the lower models. Yeah, just to test it out. I mean, unfortunately, in an emergency situation, we need something that's rock solid and not, it maybe will work, but I think we'll give this a go.
I have something to share. I've been looking at some of the other things recently, and it circles back to the problem that Matt is having with the sensor feedback. So, you must have seen the Anibotics animal robot. It's from the ETH Zurich guys. They created like a company out of it, and now they're making these robots. Interesting thing to see about this is what is the actuators that they're using. So they're selling these actuators. What's interesting about these actuators is they have a processor built in for the controls part. Also, these robots have 3 i7 processors on board, and one of them is dedicated just for the controls side of things. Now, you can imagine the level of calculations that they need to do to make a system as stable as these guys are. But for our purposes, I think it would be interesting to just have an on-board controller. For example, with Matt having a servo there, just having a servo that would have an incorporated controller, and the idea would be to just send a signal from our ROS control part to the actuator over Ethernet, because recently more and more robots are moving to EtherCAT as a transfer medium, and they're more more robots are getting rid of sensor signal wires, because these wires, at the end of the day, do create or they're affected by flux from power cables, you know. So it's it's interesting how industry is just getting rid of these smaller, you know, these minor uh, changes or minor corrections that they need to do for getting the right sensor signal, and everyone's just trying or willing to pay to get data right out of the actuator or right into the actuator or the sensor, using a well established standard such as an EtherCAT.
Well, so, and I looked up their website. What did you say? What components are they selling? I mean, beyond the whole unit?
Oh, they're selling so they have the NE drive. If you're on their website, well, the website I shared is an IEEE website, but there's also, so this one. They're selling actuators for biped robots. Uh, this one. So they're selling the motors that the robot uses,
Mm.
and these motors are they work with they have an integrated IMU, which is interesting, which is amazing, honestly, and they use EtherCAT. Uh, so they're just selling a packet, like they're selling you an actuator that you can just hook up to your computer using Ethernet, and just set the parameters on the controller, and it would just control it. Or the control side is on there, and then there's more controls over at the main CPU, main control CPU, because they have 3 CPUs on board of this robot. Like, that's fantastic. Lots of calculations that they do.
So that's more of the trend of pushing the processing power to the edge and then doing all of that locally, and then having a high bandwidth, stable connection for communications.
Yeah. So they're well, when we talk about edge, it differs, because most of the edge computing examples or mentions are about how it differs from the cloud to the edge. So so when we're doing something on the robot itself, it's called edge computing. But this is like the next level of edge computing, where you put it on the actuator itself and not on board, because the computing is still done on board, but it's also done on the actuator. So
And so if I look at the any drive robot joint, I was looking for how much torque this thing can control, thinking, could this actually be the steering control for like a lawn tractor? I'm looking for...
it would be an overkill to use this exact drive for a simple application as a rotation, because these joints are meant for like more access, uh, specifically for a biped or a quadped. So if you see them walking on the other website, like you'll realize the motion that it provides, or the kind of motion it would, and these would be like super costly to implement. Like I bet they're like a couple thousand or more per drive. Uh, it, I would recommend you to look at the animal link that they have right beside the tab. I'll share it here, but look at how they move. It's fantastic, but possibly definitely an overkill for our applications.
But the motors themselves are a single axis motor, right?
I don't. I doubt so. do you because they're just using one each for a leg, or no? Oh yeah, maybe.
It looked like they had 2 per leg.
Oh yeah, they're 2 per leg. I thought there were 1 per leg, but interesting.
So a low-cost solution that Earl Brain was working on, and they have a more advanced solution now with HROS, but using those STM embedded boards, and then you can run ROS on that, and then you talk CAN. So CAN is a differential signal, so it's well used, documented in noisy environments. So you use CAN, and then you put the little STM embedded system on your actuator itself, and it can read sensors and control motors. That's a super low cost way to push the control to the edge, the processing to, I don't know if you want to call it edge, but
Yeah, I think the edge, it would be edge of the edge.
the extreme edge.
Yeah, the extreme edge.
When you're talking about the motor controller for movement, I don't know how much closer you can get to the edge.
Yeah, the idea is to just give it a command, and it would just maintain the control. And it's kind of the same as what we're doing with it. It's just that it's not integrated. So say Matt's microcontroller is right, like you stick it onto the motor, then it would be basically doing it all on the edge. If you just program a PID control on that microcontroller, it's we're controlling it on the edge, and we're just sending or relaying the message of a steering angle to the microcontroller. The difference is that these solutions, they tackle the other things that come with sticking a microcontroller onto a motor, and that's the only difference between what they're doing and what we're doing.
Right.
They're just doing it more in a more costly way than we are. Yeah.
Okay, guys. Jeff also made a post there, so remember to save the chat if you want Sohin's links or Jeff's links there. It looks like electrical noise reduction. Okay. Have a great evening. Have a great weekend. We'll see you on the Slack channel.
Yeah. Thanks, Al.
See
Thanks,
you guys.
everyone. See ya.